A very good morning to all. I hope all are fine in this pandemic. My dear students, today I am going to discuss about a very important topic known as Clipper circuit. And why so important? Because if you go through any competitive exam question paper like GATE, IS, DRDO, bar, definitely you'll get one question of the 2 marks from the clipper and clamper. So let us say what we mean by the clipper. That this is my system, and we know any system have an input and the desired output. Input, output. Let us say the input is a pure AC signal, sine wave. In the output, if I want to get back only the positive half of the input, that is from here to here, 0 to pi, and we have to remove this part. I don't need the negative half in the output. To get back this only positive half of the input in the output, here we have to design a circuit, right? And that circuit is known as clipper circuit. In the second condition, I want to get back the negative half of the input, and I have to remove this positive, right? So this clipper is known as negative clipper, and here we have to remove this positive half to get back only the negative half. Such a clipper is known as positive clipper. In certain application, we have to remove some part of positive half and the some part of this negative half. I mean to say, in the output I want to get back certain portion of positive half and the certain portion of negative half. So this circuit is going to remove the unwanted portion of this positive half and the unwanted portion of this negative half. And this is my desired output. This in this condition, this is known as combinational clipper. So broadly we can classify the clipper as positive clipper, negative clipper, and combinational clipper. Now let us see. Whenever we have to design the clipper circuit, we are using the two components. So one resistance and another one is a diode, right? And if the diode is connected in this way, which is in parallel with the output, such a clipper is known as shunt clipper. This is the input, and the output we are going to get in parallel with the diode. And if you see the circuit diagram, how much the battery is connected with this diode, here the battery voltage is 0 volt, right? So if a 0 volt battery is connected with the diode, such a clipper circuit is known as unbiased clipper circuit. So the name of this circuit is given as unbiased shunt clipper. Now let us say this is my input voltage having the two half, positive and negative, 0 to pi, pi to 2 pi. So if you see this time interval 0 to pi, the input voltage is going to appear at the node of this diode. For example, let 0 to pi may the voltage is 1 volt, 2 volt, 3 volt. So if you apply any voltage within this time interval, diode is in the on state. And once your diode is in the on state, we have to replace an ideal diode by simply short circuit. So the equivalent circuit become like this. And your output become 0 volt. If you go with the second condition from pi to 2 pi, in pi to 2 pi interval, your diode is off. Because within this time interval, the input voltage is less than 0 volt. So any voltage coming less than 0, for example, minus 1, minus 2, minus 3, that voltage is going to appear at the anode of this diode. And because of that negative voltage, the diode is in the off state. And now, if you draw the equivalent circuit, we have to replace this by open path. So this is your V out and this is V in, and here output is nothing but V in. So 0 to pi time interval, the voltage at the anode of the diode is greater than 0 volt. Diode will go in the on state. We have to replace this diode by short circuit. From pi to 2 pi time interval, the voltage coming at the anode of diode is less than 0 volt. Diode is in the off state. We have to replace the diode by open circuit. Now if I am going to draw the output waveform, this portion is going to be clipped. In the output I am getting this part only. So this is the example of positive shunt clipper. This is the example of positive shunt clipper because this positive half is going to clip by this circuit diagram. In the same way, if I am going to apply some voltage here, case 2, let us say a battery is connected with the diode. Let us say this battery is 5 volt. And if I want to get the output for the given input, let this is my input voltage. From plus 10 volt to minus 10 volt. This is 0 volt. Right? So what to do? What is the voltage connected with the diode? Plus 5 volt. So plus 5 volt you draw here in the input. And this is the symbol for positive clipper. this circuit is going to clipped off the input beyond to this 5 volt. Means ki in the output this portion is going to be clipped off. From 5 volt to 10 volt is not going to appear in the output. The range of output is from minus 10 volt to plus 5 volt. Any voltage beyond this 5 volt, 6 volt, 7 volt, 8 volt, this diode will be in the on state and the output become equal to 5 volt. So let this point is A, this point is B. Just you draw 3 horizontal line, one of plus 5 volt, another of 0 volt, and third one of minus 10 volt. Any voltage beyond this 5 volt in the output will get only the 5 volt. So from A to B the output is 5 volt. And any voltage below to this 5 volt output is nothing but equal to input. We'll get like this. Right? So this is one example of positive biased shunt clipper circuit. Right? And in the third condition, now if I am going to change the position of battery like this, this is the input and this is output. So here the battery voltage is not 5 volt, it is minus 5 volt. So this is minus 5 volt. And the position of diode indicate it's a positive clipper circuit. So any voltage beyond to this minus 5 volt, any input voltage beyond to this minus 5 volt is going to clip by this circuit diagram. So the range of output here is only from minus 5 volt to minus 10 volt. So let this point is C, this point is D. Draw a vertical line which is going to intersect at this point C, D, and यहाँ से 1 voltage of minus 10. So any voltage beyond to this minus 5, output is always minus 5. And any voltage below to this minus 5, output is going to follow the input. So thank you all. This is all about your positive shunt clipper circuit. Right? So only the 2 points you have to remember here. This is the position of, if the diode is connected in this way, this indicates circuit is a positive clipper circuit, and the clipping takes place always with respect to the battery voltage. If no battery is connected, means the clipping is going to take place about this 0 volt. If a battery of plus 5 voltage is going to be connected with the diode, any input voltage beyond to this 5 volt is going to clip by this circuit. Here if you apply 6 volt, 7 volt, 8 volt, 9 volt, 10 volt, this is always in the on state and we have to replace this by short circuit. And in the same way, if I am going to apply a battery of minus 5 volt, the circuit is going to clip any input voltage beyond to this minus 5. The range of output is from minus 5 to the negative of V max. Thank you all.